Hello students, in this video we are going to discuss about the series combination of electric cells, and we are going to derive the equivalent EMF of the series combination of the electric cells. To find this, first of all, we will write the potential difference between the 2 points A and B of the cell E1. So this cell E1 has the EMF E1 and internal resistance R1. Another cell of EMF E2, internal resistance R2. These are connected such a way that the negative terminal of the first cell is connected to the positive terminal of the second cell. Now these two are in series combination. Its equivalent cell will have the EMF E equivalent and internal resistance, suppose say R equivalent. How R equivalent is related with R1 and R2, how E equivalent is related with E1 and E2. So we will start. The potential difference between A and B, VAB, is equal to VA minus VB, that is equal to E1 minus IR1. What is I here? The current passing through the cells is, suppose say, I. Similarly, the potential difference between B and C is equal to VB minus VC, that is equal to E2 minus IR2. Take this one is equation number 1, it is equation number 2. By adding equation number 1 and 2, we will get VAB plus VBC acts as like VAC. This one will be VB will be get cancelled here, that is but VA minus VC. We are getting here E1 plus E2 minus of I into R1 plus R2. Now we will write VAC is equal to E equivalent minus of I into R equivalent. We can write it is equation number 4 and the previous one is equation number 3. Compare equation number 3 and 4. That means from equation 3 and 4, we will write E equivalent is equal to E1 plus E2 and R equivalent is equal to R1 plus R2. Right. So based on this, we will discuss few points. E equivalent is equal to E1 plus E2. That is sum of the individual EMFs is equal to the EMF of the combination. Few points we will discuss here. Previous we have discussed connected the cells are as shown previous. Now here I am connecting the same cells like this of EMF E1, internal resistance R1, EMF E2, internal resistance R2. In this case, E equivalent is equal to E1 minus E2 if E1 is more than E2, or this one will be written as E2 minus E1 if E2 is more than E1, and R equivalent remains same, it won't change. Suppose if I am taking the n number of cells connected as shown, like this, n number of cells I have taken. All cells are identical, so their EMFs are equal as shown like this. There are n number of identical. So then E equivalent is equal to, we will get n times of E, and R equivalent is equal to n times of R if all are having the same internal resistance R. Suppose if any one of the cell is reversed, suppose if I am taking this one cell is reversed like this out of n number of cells, then E equivalent will be n times of E minus 2 times of E, but R equivalent will be remain same. And we will discuss one more point. Suppose if there are n number of identical cells are connected, and externally we are connecting to an external resistance, suppose say capital R, and all are having the EMF E, that is identical cells, these are having the internal resistances R. Then the current I here is equal to, we can write E net divided by total resistance R net. E net is nothing but n times of E, and R net is equal to the total internal resistance, that is n times of R plus R. It is the value of the current in the circuit. This is about the series combination of electric cells and their equivalent EMF. Thank you.